All right. Very good, Gene. I like. All right, well, it's time for a quiz. So, tell me, what is a gene?
Okay, genes are like the strains of code that are found along DNA, and well, it's just like kind of a blueprint that like shows how our body works and also how we look like.
Very good. Okay, well, let's try this one. What is a genotype?
Genotype is a combination of the genetic code that are inherited from our parents.
All right, good. You are learning. They're not Levi's. Okay, well, let's see. Let's do what is heterozygous and what is homozygous.
Well, heterozygous means that there are two different versions of the same gene, and homozygous means that they're the identical version of the same gene.
All right, I think you've passed so far. But now it's time to move on to something different. It's something a little more. It's called complex inheritance. So far we've learned about simple inheritance, which is kind of the standard way that Mendel did it. But sometimes the inheritance of genes isn't as simple as just it being dominant and one being recessive. There's two different terms. One is codominance and one is incomplete dominance, where it means that the dominant gene does not overshadow the recessive gene. Okay, I do not like red. There we go. So let's take, for instance, flowers, since plants have just been such a big part of inheritance. All right, we have our Punnett square here, and we have a red flower and a white flower. All right, so we're breeding these two guys. And the alleles for this are going to be obviously white, white, and red, red. So this is what we're going to get. Red, white, red, white, red, white, red, white. Now normally we'd ask, okay, but which gene is dominant, which one is recessive? Well, in this case, none of them are. This is what we call codominance. Codominance, which means that both show up equally. So we get a flower that has a mixture of white and red, or like a Dalmatian. It's both black and white. Or like a zebra, it's both black and white. White doesn't dominate and black doesn't dominate. They both show up equally. Does that make sense? I'll take that as a yes. Okay, so let's move on to incomplete dominance then. All right, so let's go back with our red and white flower. This time they're going to have incomplete dominance, which means that one gene is dominant. However, it's not, wow. However, it's not completely dominant. Incomplete dominance. This is why I like science and not English. Okay, are you watching? So we have red again. And we have white. Except this time, white is going to be recessive, little w, and red's going to be dominant. So when they mix, we'll obviously get this. But instead of getting a red flower or a white flower, we get pink flowers because the red doesn't completely cover the white. It only partially covers it. So we get pink flowers here, and then we get white and yellow, or white and red polka dotted flowers here. Does that make sense?
Well, this is very helpful to understand.
Okay, you still don't understand. All right. Here, we have one gene blue, one gene red. In codominance, we will get a bar of color that is both blue and red equally. You see that? They're both there present. Now, I don't know if this is going to work, because I don't know if we can mix these two colors. But anyways, this is codominance. They both show up equally. However, if it's incomplete dominance, we get a bar of color that is both red mixed in with blue, and it doesn't work. But imagine that's purple. See? The blue doesn't completely cover the red. Some of the red shines through, which makes it incomplete dominant.
Alright, I got it. So, how do I fix my eyes?
Oh, I don't know. I mean, your family can send you money, right, to get new glasses.
Man. It just wasted my time.